Hello student. In this session we start a new article from chapter number 9 optics from the syllabus of 11th standard physics, and that article is dispersion of light. Dispersion of white light through prism. So this article we have to learn. Now first thing, everyone know about prism because you already done one experiment of the prism in the 10th standard. Now when white light is passed through prism, then that light is separated into its constituent colors, and this is called as dispersion of light. Now what is dispersion? Now let I show you with the simple diagram. So if I consider this is a prism, so this is angle A and a white light, a ray of white light is incident on the face AB of the prism. Then it refract here. Then instead of going in a straight line, it refract and separated into its constituent colors. So let I show you here three different colors. The first color here is violet. So the middle color by distance wise is yellow, and here it is red. In between this violet to yellow some other colors are there, and the sequence of the color is Vibjol. It means that violet is the first color, then after violet indigo, then blue, green, yellow, orange and red. This is a sequence of the color which we get here. Now, so this is called as a spectrum of the color or dispersed beam of the light. Now pay attention here, this different color having a different angle of deviation. So this is angle of deviation for violet color. So this is angle of deviation for yellow color, and this is angle of deviation for red color. Now one thing you remember here, so if I consider here a normal, then this angle is the angle of incidence. Then these angles are angle of refraction. Then angle of refraction for this violet light, yellow light, red light, it is a different. So angle of refraction is different for different color. So in simple word, we use here Snell's law. Hence by Snell's law, Snell's law is the refractive index of material of the prism, I use n for that, is equal to sin I divided by sin R. So this is the formula. Now for violet color, refractive index for violet color is sin I divided by sin of R for the violet. This formula we get. Similarly, for red color, I consider the extreme colors. Refractive index of the red color is sin I divided by sin of R for red color. Now if you observe this very carefully, so this is, let I show with the different pen here. So this is angle of refraction for violet. Now, so this is angle of refraction for red color. Now angle of refraction for violet color is less as compared to the red color. So as angle of refraction for violet less than the angle of refraction of red. Hence, so angle of incidence is same. This is angle of incidence. After refraction, it is separated into different colors here. So as this angle of refraction for violet is less than the angle of refraction for red, hence we can write refractive index for violet and refractive index of red we can compare here. So refractive index of violet is greater than the refractive index of red. Means for same material of the prism, refractive index vary from a color to color. Means for yellow color light, red color light, violet color light, the refractive index of material of the prism we get different. The relation we can write between the refractive index. So refractive index of violet is greater than the refractive index of yellow, greater than the refractive index of red. So you can remember the sequence of the color. So for violet, a larger refractive index, and for red, a smaller refractive index of material of the prism. The sequence is as per the name only: violet, indigo, blue, green, yellow, orange, red. So this is sequence. Now here, if we are talking about this angle of deviation, pay attention here. If I extend this, then this is the angle of deviation for red. Now if I extend yellow color line like this, then this is the angle of deviation for yellow. Similar manner, angle of deviation for violet. Now here we can conclude that angle of deviation for violet is greater than the angle of deviation of yellow, and yellow deviation is greater than the red. Means this red light is deviated least, more deviation for violet light taken. So these are the fact which we observe when the white light is dispersed. White light is dispersed. As well as you remember one thing here, white light constitutes 7 colors. So when we pass white light, it separated into its constituent colors, means it separated into 7 colors. You can see here. Now here, by sequence wise, green is the central color. But by distance wise, if we measure the distance from violet and red, then yellow color is coming at the center. So yellow color is called as mean color, that you note. You note yellow color is mean color because it is coming at the center of this spectrum. Take it. Then after that this mean color, yellow color is a mean color. We have to note some point about the wavelength also. So here, generally wavelength we represented by symbol lambda. Okay, wavelength we represented by lambda. So wavelength, you know that wavelength for violet color is less and wavelength for red color is more. So wavelength of this violet and red are lying between 4000 to 8000. You know that this visible light having a wavelength approximately between 4000 to 8000, that you learn in the previous standard also. Visible light means the light which we can see is the visible light, and the human eye sees the light only between the violet to the red color. So here the wavelength of the violet color is approximately 4000 and wavelength of the red color is approximately 8000. That also you can remember it here. Okay, I hope everyone understood. One more thing. So here this AB and AC, at these two surfaces refraction occur. So this angle A is also called as, this angle A is called as refracting angle. Refracting angle of prism. Refracting angle means the angle between two surfaces where refraction occurs is the refracting angle of prism, or it is also called as angle of prism. So generally this angle is very important. We have to use it in while solving the problems also. One more thing, you know that if it is an equilateral prism, then every angle is 60 degree. So for equilateral prism, we can consider here angle of, means refracting angle is 60 degree or angle of prism is 60 degree. I hope everyone understood this dispersion of light. Now let I ask simple question to you. And the question is, you know that when the white light is separated into 7 colors, if I pass a yellow light from this side, then what happened to this side? We get yellow light only. So listen, dispersion means separation of light into its constituent colors, and white light having a 7 colors in it. So it is divided into 7 colors. But when we pass a single color light and it is incident here, then refracted light is also a same color light. Means if we pass red light, we get red light here. And such light, single color light, is also called as monochromatic light. Now the word is monochromatic. Monochromatic light means light of single wavelength, or single color light is called as monochromatic light. That you remember.